Hello students, welcome back to True Tutorials. So today we are going to learn about motion, which is very important chapter in physical science. Let us start with definition of motion. What is motion? Motion is a physical movement or change in position of a body relative to time and reference point. Okay. So now if you consider this girl at 0 seconds, she was at point A. Then after 2 seconds or 3 seconds, let us suppose, she moved to point B. So here with change in time, okay, there is change in position of the body. So we can say that the girl is in motion. Now let us take another example of train. Okay, in train there are two people, A and B, and outside the train on platform there is person C. Now when train is in motion, when train starts, for person C, A and B both are in motion. Okay, but inside the train, for A, B is at rest, and for B, A is at rest. Okay, and there is one more case that for this A and B who are inside the train, for them, this person C, he is in motion. It looks like C is in motion. However, in real time, this person C, he is at rest. Okay, but according to the reference, as train is moving, okay, it looks like C is in motion. Okay, so we can say that motion depends on two things. One is time and other is reference, point of reference. Okay, so I hope you are clear with what is motion. Okay, and now we have two types of motion. One is uniform motion and other is non-uniform motion. Now let us see what is uniform motion. Uniform motion is if a body travels equal distances in equal interval of time, then it is called uniform motion. And if a body travels unequal distance in equal amount of time or equal interval of time, then it is said to be non-uniform motion. Now let us understand better with example. Now if you take example of a clock, now if you consider the seconds hand of the clock, every second it moves same distance, or every equal interval of time it moves same distance, so we can say that it is uniform motion. And if you take pendulum of a clock, okay, it moves same distance in same amount of time, same distance in equal amount of time or equal interval of time, so we can say the motion of pendulum is a uniform motion. Okay, if you know any other examples of uniform motion, please mention them in the comments below. Next, for non-uniform motion, we can take example of any non-uniform motion. For example, bouncing of ball or a person driving a car. Okay, so there are many n number of examples that we can take for non-uniform motion, because in non-uniform motion we are traveling unequal distances in equal interval of time, equal interval of time. Okay, next let us see distance. Okay, now what is distance? Distance is how far an object has moved. How far, what is distance? Distance is measure of how far a object has moved, and distance is measured in meters, kilometers, okay, or centimeter or millimeter. Okay, meters is SI unit, okay, and kilometer is MKS unit of distance. And we know that a distance is a scalar quantity. Now what is scalar quantity? Scalar quantity is a quantity which has magnitude, okay, which has magnitude but has no direction. It has magnitude but it has no direction. Magnitude means it has some value. Okay, for example, we can say that a person has traveled 1 meter, or a person has traveled 1 kilometer, a person has traveled 10 kilometers, but we don't need to mention direction, in which direction the person has traveled. Okay, so distance is a scalar quantity. Now let us see a small example here. There is a girl, okay, who is standing at this point. Okay, and here it is given that each mark is 1 meters. Okay, we have x-axis and y-axis here. Each mark is 1 meter. Okay, so let us label the marking here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so one mark is equals to 1 meter. Okay, so we can say that distance from the girl to the ball. Here we have a ball. It is 9 meters. How much it is? 9 meters. Okay, I hope you are clear with distance concept. Next, let us move to displacement. Okay, now what is displacement? Displacement is the distance of body changed in position from starting point to end point. Okay, or we can say it is the distance, it is distance between the starting point and ending point. Okay, or initial point or final point of the motion. Okay, now let us take an example to understand it better. Here in this picture we have a girl who walks to the red ball. This is the red ball. Okay, and then she walks backwards towards the teddy bear. Okay, now what we have to see, we have to see how far she has traveled, how far she has traveled. Okay, so well, let us label this 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how far she has traveled? First she has traveled from here to here, that is 9 meters. Okay, then from red ball to teddy bear she has traveled how much? 2 meters. Okay, 1 meter here, 2 meters. Okay, so 2 meters. Fine. So total 9 plus 2, it is 11 meters. How much is total distance? It is 11 meters. Okay, now what we have to do, we have to calculate the displacement from starting point. Okay, so here this is the starting point. Okay, and as we know that girl, she is moving to the ball and again she is moving back towards the teddy bear. So here it is our final point. This is our initial point. Okay, this is our initial point and this is our final point, teddy, where the teddy is there. Okay, this is our final point. So distance between initial and final point here is 1, 2, 3, 4, 5. Okay, or we can consider from here 1, 2, 3, 4, 5, 6. Okay, so it is total 6 meters. So displacement from initial point to the final point. Okay, distance from displacement from initial point to the final point is 6 meters. So to understand displacement more in a better way, let us take one more example. That is the boy, let us name Ram. Okay, he is starting from his house. Okay, and he is going to a market to buy some vegetables or groceries. So the distance from his house to market is 10 meters. So when he went to market, unfortunately the market was closed. So what he did, he went back to his house. Okay, now the question is, they are asking us total distance traveled and total displacement traveled. Okay, now first let us say how much distance Ram has traveled. Okay, so from house to market it is 10 meters and then market to house it is 10 meters. So how much? Yes, exactly 20 meters. Then displacement. Okay, what is displacement? Let us recall again. It is the distance between initial and final point. So here the initial point is house and final point is also house, because the person is going to market and is coming back to his house. So initial and final point are the same. So displacement is 0. Okay, so I hope from this example displacement concept is clear. If you have any doubts, then you can ask me in the comment section. Now, what is speed? Speed is the distance object travels per unit time. Okay, speed is distance per unit time or distance of an object traveled by per unit time. Okay, so speed is measured in meters per second. Speed is measured in meters per second. Okay, if you see in your car or if in two-wheeler, Activa or anything bike, okay, you have a meter which shows the speed of your car or two-wheeler. Okay, which shows 40 km per hour. Okay, 20 km per hour. Okay, so what is this? This is speed. Okay, and this meter which shows the speed is called odometer. It is called odometer. What it is called? It is called odometer. Okay, so this odometer shows us the speed of the car or two-wheeler. Fine. Okay, so as we saw that speed, the unit for speed is meter per second, or you can also take it as kilometer per hour. Okay, fine. So the formula for speed is speed equals to distance by time. Okay, distance is represented as s and time is represented as t. Okay, and speed is a scalar quantity. Speed is a scalar quantity, and I forgot to mention that displacement is a vector quantity. Displacement is a vector quantity. Why? Because it requires both magnitude and also displacement. Okay, it requires both magnitude and also displacement. That's why magnitude and also direction. That's why it is a vector quantity. Now let us do a small example. Given that a car travels 500 meters in 10 seconds. Okay, so it is asking us what is the car speed. We know that speed equals to distance by time. Speed equals to distance by time. Now how much is distance? It is 500 meters. And what is time? It is 10 seconds. So 0 0 cancel. The answer is 50 meter per second. Okay, writing unit is very important. Okay, unit is very important. So it is 50 meters per second. If you write only 50, then your answer will be wrong or your marks will be deducted. So please write meter per second. Okay, mention the unit very clearly. Fine, and this is your homework. Okay, after doing this, please mention it in the comment section. Let us take another example here. So we have an elevator, means lift, which travels from first floor to 25th floor of the building, and distance, it travels a distance of 100 meters in 30 seconds. How many seconds? 30 seconds. So what we have to find? We have to find speed of the elevator. So distance given here is how much? 100 meters exactly. What is time? Time 30 seconds. Okay. Now it is asking speed. Speed equals to distance by time. Okay. So distance is 100 and time is 30. 0 0 cancel. Okay. 3 3s are 9 point. Okay. Then I'll be left with 10. So 3.3. So 3.3 meter per second. Okay. This distance is 100 meter and time is 30 seconds. So speed equals to 3.3 meter per second. This is our answer. Okay. Next, let us see what is constant speed and changing speed. What is constant speed? Constant speed means that speed stays same throughout the journey. Okay, entire distance. Okay, so it is in very few cases we have constant speed. Okay, because with time generally speed will increase or decrease. Okay, and what is changing speed? When with the time, when through a journey the speed is increasing or decreasing, then it is called changing speed. Okay, constant speed means throughout the entire distance the speed is same, and changing speed means in entire distance the speed is changing, it is increasing or decreasing, it is not same, so it is called changing speed. Okay, now let us see what is velocity. Velocity is the quantity which specifies both direction of motion and speed, that is called velocity. So velocity is the displacement of body per unit time. I am telling once again, velocity is displacement of a body per unit time. Okay, so velocity is equals to displacement by time taken. So since velocity has both magnitude and direction, it is a vector quantity. It is a vector quantity. Okay. So example we can see here. See 30 miles per hour east. Okay, east is given here. So when a direction is given, that means it is velocity. Okay, speed with direction is called velocity. Now let us see average velocity. What is average velocity? Average velocity is ratio of total displacement by total time taken. Okay, so total displacement by total time, and unit of average velocity is also same, meter per second. Okay, now let us see an example for average velocity. It is given that a car travels with speed 10 meters per second for 5 seconds, and we can take it also as velocity. Okay, is velocity of 10 meter per second for 5 seconds and 20 meter per seconds for 10 seconds. What is the average velocity? Okay, so initial velocity is how much? Okay, let us see the formula. Average velocity is total velocity by total time. Okay, so total velocity is how much? 10 plus 20. Okay, total time is 10 plus 5. Okay, total 10 plus 20 is 30, and 10 plus 5 is 15. 15 2 is 30. Okay, so it is 2 meter per second. Average velocity is 2 meter per second. Okay, yes. Then moving on to acceleration. Acceleration is rate of change of velocity. Acceleration is called rate of change of velocity. And the formula for acceleration A is V minus U by T. Okay. Final velocity minus initial velocity by time. Okay. Rate here, rate means time. Okay. Rate of change of velocity is called acceleration. That's why in denominator we have time. Okay. So acceleration equals to final velocity minus initial velocity by time, and the SI unit of acceleration is meter per second square. Meter per second square, and acceleration is a vector quantity. Why it is a vector quantity? Because it has both magnitude and it also requires direction. Okay, it also requires direction. Okay, so thank you for watching the video. I hope every concept is clear till here. In next video, we'll be learning about graphs. Okay, we'll be learning about velocity time graph, velocity time graph, displacement time graph. Okay, and we'll also be learning about equations of motion. Okay, so stay tuned for new video. Don't forget to subscribe our channel, like the video, and click the bell icon so that as soon as we upload video, you get the notification.